our first section, we're going to be finding the derivative by the limit process. And of course, we're going to start with something easy, because this process can get pretty nasty. So let's say f of x is equal to, we'll just say 2x. All right, so that'll be our function. F of x is equal to 2x. Now what we'll need to do now is go ahead and write this formula that we're going to be using, and that is f prime of x, f prime of x is equal to the limit, and sometimes this is written differently. Sometimes there's an h here, but we're going to go ahead and use delta x. All right, we're going to go ahead and use delta x. Okay, I remember when I first learned it, they put an h there for whatever reason. So the limit as delta x approaches 0 over, so I'm going nice and slow here, so you should be able to write this stuff down as I'm writing this stuff out here. All right, and let me just copy and paste that. Okay, so is x plus your delta x minus f of x. Now you may think this looks complicated, but I promise it's not. All right, and this is all going to be over delta x. Okay, so this is going to be, this f prime of x is going to be your derivative. That's what we're going to be finding. All right, is equal to the limit. Now we must say as long as the limit exists. All right, as long as the limit exists, we'll be able to find f prime of x. All right, so by using this formula here, first thing I'm going to do is I'm going to go ahead and write this one here out, this f of x plus delta x, and we're going to do that one first. All right, let's go ahead and do that one first. And actually, what I want to do here is well, is it going to let me? I guess not. Okay. So we have f of x plus our delta x is equal to, now what we're going to do is we're going to take this x plus whatever's in parentheses right here, we're going to take this and plug it right in for this x right here. Okay, in other words, this x right here is going to get replaced by whatever's in parentheses right here. All right, so that means you're going to have 2 times, okay, x plus delta x. So whatever's in parentheses right here, whatever this is going to replace this x. All right. I know when I was first learning this stuff, man, that was hard to understand that, because I always got this x and this x mixed up, and these are two different things here. This is everything that's in parentheses goes in right here. All right. What we'll want to do here is go ahead and distribute that 2 all the way across if you want. All right, if you want, but I think we'll probably leave that off for right now. All right, so now I'm going to go ahead and rewrite this whole thing. And actually, instead of rewriting this whole thing, I think what I'm going to do here is see if I can't just copy paste that whole situation right down here. Okay, so you should be able to keep up with me here. All right, so that's going to get replaced with this 2, right, x plus that delta x. Okay, we're going to replace that. All right, you see that? So that got replaced, and then of course our f of x, the f of x is 2x. So you see that? That's all we got to do. Okay, that's all we got to do. Now what we'll want to do next is go ahead and simplify this. We're going to go ahead and simplify this thing down. And of course, I think what I'll do here is just, we'll just copy and paste it. All right. And up here in the numerator, I'm going to go ahead and distribute this 2 across, which means that'll be 2x. And then we'll put a 2 there. We're just distributing that 2 across. Okay. Now you see up here in the numerator, we have a negative 2x and a positive 2x. So 2x minus 2x is going to be 0. And so we're going to end up being left with, all right, so we're going to end up being left with just 2 delta x in the numerator. All right, 2 delta x in the numerator. So let's go ahead and just copy and paste that. All right, so hopefully you're able to keep up with what I'm doing here. So that's just going to disappear, and that's going to disappear there. Now you notice we have a delta x in the numerator and a delta x down here in the denominator. Well, those guys are just going to cancel out. Okay, those will just cancel out, and we're going to just be left with, as you can see here, we're going to be left with the limit. So hopefully you know something about the limit. Hopefully. All right. Even though I'm not covering that, I'm covering that in the next section, or the next group of videos at some point in time. But I do have a website that has all that on there. All right, so the delta x over delta x cancels out, and what are we left with? We're just left with 2. That's it. We're just left with 2. And if I can write that in there, yeah. So the limit, so you should know that the limit of a constant is just the constant. So this whole thing is just equal to 2. I guess to use the same font, we need to probably get inside there. Okay. All right. So there's just a little bit of work to that, not much. So what did we figure out? We figured out all this right here is equal to 2. See that? This whole thing right here is equal to 2. Maybe we should just write that in up here so it doesn't look too confusing. Write it in is equal to 2. So what does this mean? This means that f prime of x, and I think what I'll do is I'll just go up here to the top. So we were trying to find f prime of x, right? That's what the goal was. F prime of x is equal to 2. All right, f prime of x is equal to 2. And of course, this is simple. This is just a linear function here, 2x. Oh boy, these things start getting difficult when this x becomes a square or even a cubed. Right, this starts becoming really nasty right here. All right, really nasty. Okay. So there we go. The goal was to find f prime of x, and we did, and f prime of x is equal to 2. All right, so we're going to work about 4 more problems using this definition, the definition of the limit.
1.
All right, in the previous problem we said that the function was 2 times x, and let's get rid of that. And we found the derivative was 2. Maybe you'll see a pattern. All right, so let's look at a different one here. Let's put a 3 here, and let's add a constant. We'll add 1. Right, we'll add 1. So we have f of x is equal to 3x plus 1, and we're going to want to find f prime of x. x. Now, using the definition. Now, of course, I'm using f. F is a little overrated, I'd have to say. We could be calling our function anything. This could be g, h, could be a name, who knows. You can write anything you want here. All right. All right, so the goal is to find what is f prime of x using the definition. And of course, we have to say as long as that limit exists. Okay, so the first thing I'm going to want to do here is I'm going to go ahead and I'm going to want to find this so we can plug this into our formula. We want to find f of x plus delta x. All right, that's the very first thing that we want to find. So remember, x plus delta x gets substituted in right here for this x. All right, so that's the very first thing we want to find. F of x plus delta x. Wish there was a shortcut key for this delta sign. Delta x, all right, is equal to 3 times, and instead of me writing all that in, I'm just going to copy paste it here. Right, make life a little easier on me. Okay, and then of course we have plus 1. So what we'll want to do here is go ahead and distribute this 3. Go ahead and distribute the 3 across. Okay, so that's what we'll want to do. And I think we'll just copy paste this whole thing. I think I could hit select all somehow on that. All right. Okay, so that means we're just going to knock that down. So we have 3x plus 3 delta x. Go ahead and get rid of that. All right. So as you can see, that 3x plus 3 delta x plus 1 is going to be going in right up here. Right. It's going to be going in right here where this is located. Okay. See that? All right. Which means that we're going to go ahead, highlight all that, move on down. Okay. All right. And okay, so you should be able to keep up with what's going on here. Hopefully, probably write it out faster than I am. I've kind of chosen to do it this way. Instead of writing on a tablet, it just seems like there is no mistake on what's being written on the screen here. So we have 3x plus 3 delta x plus 1 minus f of x. Now remember what our f of x is, and you must start a parentheses on this one. Always put a parentheses around your function. If you don't, you're going to end up getting this thing wrong, because you see this minus sign right here. Pretend that's like a -1 right here, and you need to go ahead and distribute that across inside. Okay, even though the 1 is not written in. All right. So once we do that, this negative sign here needs to get distributed across. Okay. So it's a common mistake. It can easily be made. Let me tell you. I mean, I still make plenty of mistakes, and I've been doing this stuff for years. All right, let's go ahead and take that down. Okay. All right, now what we can do here is we can go ahead and simplify this thing down. And of course, what I'm going to do is Control A. No. Trying to remember. Whoops. I didn't want to do that either. That select all didn't do what I wanted it to do. Okay, we're just going to go ahead and do it this way. Okay, so let's go ahead up here in the numerator. And so we have that -1. we have a plus 1, so those are going to disappear. And also that minus 3x, and we have a plus 3x. So you see that's going to disappear also. Subtracting off the function. Now, as you can see here, we have a 3 delta x and then a delta x down in the denominator. So the delta x's are going to cancel out. Okay, the delta x's will cancel out. So, you know, majority of the time when we're doing calculus, we end up spending most of our time just doing algebra, doing intermediate algebra. I mean, that's what we spend most of our time doing. Okay, so because the 2 delta x is canceled out, right, this delta x and this delta x is going to cancel out, we're just going to be left with 3. So the limit is delta x. Once we simplify this thing down, and so once again we have the limit of a constant, and the limit of the constant is just the constant, which is actually 3. So what could we say up here? Well, we could say that f prime of x is equal to 3. Right, so hopefully at some point here you'll start seeing a pattern, maybe of some kind. And of course, when we actually get to the rules of differentiation, we won't be going through all of this. Right? Okay, they got to drag you through the mud first. And actually, instead of, it's called the eliminating students out of the class. Yeah. If not everybody on the planet would be an engineer, if calculus was easy. I know, isn't that crazy? Okay, so that takes care of that, and we got we'll work 3 more problems on this.
One.
All right, so we're moving right along here. I think in this particular one, this problem, we're going to rename our function. All right, in this one here, let's go ahead and do x squared. And also, let's rename our function. We'll call it g. How's that? Doesn't have to always be called f. We'll call it g. Okay. And of course, we're looking for g prime of x. Now, if we do this, we must just go ahead and see, we're still doing delta x. Maybe we could change that too if we want. And we'll just call it small g. It doesn't matter. Capital G, small g, it doesn't matter. All right. Just going to show you that we can actually call these anything we want. Okay, so we want to find g prime of x, and we're going to use the definition of the derivative here. So what's the first thing we're going to be doing? All right, this should be our 3rd problem now. We're going to be finding this guy here. Okay, so that's going to be the first thing that we want to do. And of course, it doesn't let me copy paste that. I'd like to try to use keyboard shortcuts if I can without touching the mouse. Okay, so we're going to have g of x plus delta x. I guess it's not going to let me do that. So let's, all right, is equal to. Now remember, whatever is in parentheses right here, okay, this x plus delta x is going to be going in right in here for this x. Okay, so you got to keep that in mind. Keep that in mind. All right. Keep that in mind. I know it took me a little bit of time to wrap my mind around that when I was first learning this stuff. All right. So we're going to go ahead and put a parentheses. Okay. And squared. So we're going to need to multiply this thing out. We're going to need to multiply this thing out, as you can see here. This x plus delta x. But I think what I'm going to do is, I think, instead of skipping too many steps, we're going to go ahead and skip too many steps and you'll get confused. All right. So this x plus, or this piece right here, okay, what's going to go in there? Well, it's going to be this whole thing right here. The whole piece right there, that's what's going in. And we'll multiply that out here in just a second. But I want to show you this so you see the big picture. Okay. All right, and of course we have x squared because that is our function. Okay, but what we're going to need to do is we're going to need to, this thing is squared. We're going to have to do some math here. We're going to have to do some algebra. That's what we're going to have to do. And we're going to go ahead and come right down here and do that. All right, so this is equal to what? We have two of them. It's x plus the delta x, right? X plus delta x. X plus delta x. Right? Right? See that? There's two of them. Okay. So this is that intermediate algebra stuff that we got to refresh your mind with. So we need to go ahead and multiply this thing out. Right? So you always multiply the first terms, x times x, which is equal to x squared. I guess we'll try to get this all on one line here. Is equal to x squared plus, hopefully, you know what, I don't think we're going to have enough room. So let's just go ahead and move it on down right there. All right, we'll just move it down to here. So x times x is x squared. And I don't know why, oh, it went down to 18. Okay, we want to kind of keep it a little bit larger font is what we want to do here. Okay, it looks like it's going to stay. All right, so x times x is x squared, and then we have x times delta x, x times delta x. Copy that delta x. So that's going to be plus x times delta x plus, then you have delta x times x, delta x times x, delta x. I'm going to go ahead and just put parentheses around that because that looks kind of funny, putting that x and then that other x next to it. And then plus the last term, which is delta x times delta x. So delta x times delta x. That doesn't look too bad there. Now we can go ahead and simplify this. And what we could actually write here is an equal sign. Okay, meaning that we're carrying this line down. Okay, carrying this line down. And I think because a lot of this we're going to repeat, I'm going to go ahead and just copy that and paste it. Okay, so we have some like terms in here. We have an x delta x and a delta xx. Those are the same things. All right, so let me just go ahead and that means there's two of them. Right, there's two of them. Two x delta x's in there. Okay, and this guy here can actually be rewritten. We have delta x times delta x. It'd be like saying x times x is the same thing as x squared. It's the same thing as x squared. So what we could do here is, let's see, I don't know. Let's do this. Okay, so this is really assumed to be 2x, or delta x. Squared means there's two of them. It would probably be more appropriate to maybe do this, saying that the whole thing in parentheses is squared. I think that's what we'll do there. Okay. All right, well, finally, we have this up here. Okay, so we had to multiply all that out. And remember, that's going to get placed. That's going to get placed right up here. Okay, that's going to get placed. So that's going to be the next thing we do. We're going to go ahead. We're going to go ahead and rewrite that. So we had to do a little side work on that one. And that's what I'm saying. These things can get really nasty. Now, we're going to have shortcut methods for all this later on in the story. Right? That's what the rules of differentiation are all about. Shortcuts. Okay. So that's going to go in right up here in the numerator. Boom. All right. And of course, we don't need this equal sign. Now, minus g of x. Now, what was g of x? Well, g of x was just our x squared. Right? G of x was equal to x squared. Okay. So as you can see now, by looking at this, we're going to be able to cancel some stuff out. We have an x squared minus an x squared. You see that? An x squared minus an x squared. Okay, so let's go ahead and just, we're going to go ahead and we'll go ahead and just rewrite all that. Okay, and I'm going to say here that I want you to finish this. So these are going to get eliminated. We're going to be left with a 2x delta x and a delta x squared. We can cancel out a delta x and cancel out a delta x up here. And what's going to happen here is we're going to be left with 1 plus delta x. And then once we plug 0 into that delta x, 1. Well, I noticed something here. I was going to try to let you work this out, but as I was explaining this, I noticed that I left something off up here. So we have an x delta x and a delta x x. Now that means that there's two terms that are the same, so they're like terms. There's two of them, and this should be 2x, and I'm going to go ahead and put a parentheses around this. Whoops. Delta, actually, I guess I don't have to put a parentheses. I was thinking maybe I should, but maybe I don't have to. So you see there's two of these terms here. There's an x delta x. We have an x delta x and an x delta x, or delta xx, same thing. And we have two of them. And I noticed that I left this off when I was going back and explaining this. So I left off, actually, I mean, it is a big deal there. Okay. All right. Yeah, that's a big deal. Don't get that right, our problem will not be correct at the end. Okay, so I'll lift that x off. All right, so going back here, so we have an x squared and a minus x squared. So as you can see that we can go ahead and cancel this out. Go ahead and get rid of them. Whoa, I didn't want to do that. Darn it. That I did not want to do. Actually, you know what? Darn. Okay, maybe. There we go. Okay. All right, so let's get rid of that. Okay. Now, as you can see here, we have a delta x, and then we have two delta x's. So that means that we can cancel, since we have a delta x down here in the denominator. Here's those intermediate algebra rules again. Since we have this delta x down here in the denominator, right, we can cancel one delta x out of here and one delta x out of here. Right? Okay. So we're going to rewrite all this. So hopefully understand when we talk about this intermediate algebra rules, I don't really want to have to spend any time explaining intermediate algebra. All right, so we're going to be left with a 2x plus a delta x All right, 2x and a delta x. Now what we'll do now is the direct substitution, and that is plugging 0 directly in to this delta x up here, so we end up with 2x plus 0. But 2x plus 0 is just 2x. See that? 2x plus delta x, or 2x plus 0 is just 2x. All right. So let's come back up here. We finally found the derivative using the definition. Boy, what a nuisance that is. Anyway, okay, so g prime of x is equal to 2x. Are you seeing a pattern yet? There's a pattern. All right. Okay, so let's see. That's the third problem. I said we'd work 5 of them, and they're getting a little bit more difficult as we go. If you haven't already noticed, that. All right.
One.
Okay, in our last problem, let's go ahead and let's get a new problem here. I think we'll go ahead and keep that. Let's give it a coefficient of 2, and what else? Plus 2. Let's do that. And let's do something else. Let's call our function, we'll call it h. How's that? And we're going to be looking for h prime of x. H. Of course, we'll need to go up here and change this. I mean, we don't have to, I don't guess. Yeah, if you understand what's going on here, you shouldn't have to. All right, but we'll do it anyway. Okay, because most textbooks consider this h here to be f, and so you have to kind of adjust your mind to what it is that you're finding. All right, so we want to find h prime of x using the definition, considering that the limit exists. Right. So what's the first thing we do? Well, we find h of x plus delta x. And that means that we're going to plug that x plus delta x in right here. See that? Okay. All right, so we have h of x plus delta x that's going in, substituting in, so we're going to have 2 times x plus the delta x. Now, I think what I'm going to do in this problem is kind of skip a step or two, because if you were paying close attention to the last problem, you know that we've already worked this out, right? Squared. We've already worked that out. So you'll need to refer to that last problem, because I'm going to just assume that you know how to multiply x plus delta x, right? Square it, just like we did in the last problem. Okay. So I'm going to go ahead and what do we want to do here? You know what? I think instead of going ahead and plugging, yeah, let's just do that before I multiply it all out. Excuse me. We'll go ahead and copy paste all that. All right. And I think, yeah, we'll just do this. Okay, so all that gets put in for where that h of x plus delta x was at. There we go. Minus h of x. So what's our h of x? Now remember, we're going to have to put this in parentheses. you don't put this in parentheses, you're going to be in big trouble. All right, because you'll forget to distribute that minus across. So remember, don't forget to put that in parentheses there. And we're going to want to now simplify this out, and that means we need to multiply this guy out because it's squared. And I'm not going to go through all those steps like I did in the previous problem on that. Okay, I'm just going to go ahead and I guess I'll do a little bit of it, but all right. Okay, so we have x plus go ahead and put the parentheses here. Let's see, x plus our delta x plus our delta x is equal to, remember, x squared plus 2x, I'm going to get it right here in a minute. Oh, goodness. Delta x plus, and I'm going to go ahead and put parentheses around this, plus our delta x squared. Okay. So remember how we did that in the previous problem. Okay. So that's all multiplied out. So what are we going to do with this 2 now? We're going to distribute it all the way across. We're going to distribute it all the way across. So I think maybe what I'll do here is I think what I'll do is I guess we won't skip too much of it. Go ahead and I'll just rewrite it. Remember, there's a 2 out front, so that means we need to distribute this 2 across, 2, and that's going to make that a 4, and we'll put a 2 there. Okay. All right. Now, what else? What else we got going on here? Well, we still have this 2 right here, so we've got to add 2 to it. Okay, got to add the 2 to it. So hopefully you'll be able to figure out what I'm doing here. So what I'm going to do now is go ahead and we'll rewrite that. Okay, so up here in this denominator now, remember we figured out with this portion, this part right here that I'm going over, okay, we know what that is now. So we're going to go ahead and erase that and write it in. It's 2x squared plus our 4x delta x, 4x delta x plus our 2, and I'm going to go ahead and just continue to put parentheses around this thing. Right. Squared there. And of course that end is plus 2. Now remember what we got to do here is we got to distribute this negative across. Okay. Distribute that across and then go ahead and get rid of that. All right. So now what we can do is go ahead and simplify this thing. Why is that arrow like that? I don't know. We have a 2x squared. We have a minus 2x squared. So those are going to cancel out. We have a plus 2, a minus 2. And those are going to cancel out, and that looks like that's going to be it for the like terms in that. All right, so let's, I guess instead of rewriting all that, we'll do another copy paste. All right, so let's go through and all right, so we have a -2, that's going to cancel, that's going to cancel, and then we have right that 2x squared. Okay, so as you can see here, we have a delta x, and we have two delta x's. We have this delta x in the denominator, so we're going to be able to cancel that delta x out because we have one here and we have two of them here. All right. Okay, so let's see what that's going to give us once we do that. Cancel, Control B. All right, so we're going to end up with 4x. Whoa, we need to get inside that box. We have a 4x plus a 2 and then a delta x. 2 delta x. So what do you think this is going to end up being? Right? It looks like it's going to end up being, when we plug all this in, we're going to get a 4x. A 4x looks to me like it's going to be our answer. Okay? So we end up with h of x is equal to 4x, and we're done. Bam. Got it? See that? You see a pattern yet? There's a pattern. Okay, there's a pattern.
2, 1.
All right, this will be the last example that we'll be working. In this particular one here, let's see, what kind of, I went ahead and named the function O. All right, just demonstrating that we can name our function anything we want. You can put any kind of symbol you want right here. Right? And actually, those should be, let's see, I guess those are small x's. Wonder what a big X looks like. Oh, okay. They look like capital X's. We want to use small case. Let's do a rational function. Let's do 1 over x. How's that? 1 over x. Okay, so we want to find O prime of x. And we're going to do that by using the definition of the limit, as long as this limit exists. So what's the first thing we're going to do? We're going to find this guy right here, and that means we're going to take this x plus delta x, and we're going to plug it in right here. Okay, so let's go ahead and do that. Go ahead and do that. And it looks like it doesn't want to use the same size. Okay, there we go. All right, so we have O of x plus delta x. X plus delta x. I noticed in the other videos that the screen was kind of jerking around. I'm hoping that what I've done here is has fixed that problem, because that was kind of getting on my nerves. All right, so we're going to take this x plus delta x and we're going to put it in the numerator here. And I think I'm going to try to just copy that. If I can, let's copy paste. Okay, so there it is. We put the x plus delta x down there in the denominator. All right, so now what we're going to do is go ahead and rewrite this. So once again, as usual, we'll be dealing with some intermediate algebra. These intermediate steps, man, they massacre most students, let me tell you. All right, so this right here, we found that, and maybe we can do this here. Let's see what we can do here. Yep. Right. Yeah, instead of using a tablet, I have decided to go this route for right now. See how this works out. So this was going to be 1 over x. And I think maybe I can just do that and then edit. Okay, so there you go. Oh geez, now what do we do? Well, we got these two fractions up here in the numerator, and we need to get this all into one single fraction. We got to get that into one single fraction. Yeah, how are we going to do that? Right? And I've tried to copy paste these things up here before, and it doesn't work out, whatever the reason is. So I think what we're going to do is we're going to go ahead and just do some side work on this. All right, do some side work, little side work. Okay, so we need an x over x over up here. So I'm going to, all right, so I'm going to put an x in the numerator. And then, of course, we're going to be putting an x down here in the denominator on top of what's written in the denominator, and that's x plus this delta x. Right? Dealing with intermediate algebra. All right. 1 over. Now, what do I not have in the denominator down here? Well, I need this whole thing. I need this x plus delta x down here in the denominator. And if I put it in the denominator down here, I got to put it up here in the numerator also. Right, in the numerator also. So we end up with x plus delta x. Write that up there. And then we're going to have an x plus delta x right in the numerator. Got to write back down here in the denominator. And then, of course, we have an x already. See that? Okay. All right, now we have two fractions here, and they have common denominators. So that was the whole idea, common denominators. Maybe back in school they'd said, I'll just do this. Take this x, put it up here, take whatever down here and put it up here. And then, of course, multiply them both together, and that's pretty much what we did. Okay, so now we have a common denominator, and now we can write this as one single fraction. So we're going to have x, so I better do this first, x minus, okay, just add their numerators, x minus, now remember, you need to put a parentheses here, x plus. Why are we putting a parentheses? Because we have that delta x. I mean, not that delta x, we have that minus right here. And putting a parentheses helps us to remember we've got to distribute that across. Okay, distribute that across. And of course, down here in the denominator, we have x, and then x plus delta x. Man, I wish there were shortcut keys for this stuff. X plus delta x. Okay, so writing it as one single fraction. Now what we need to do is go ahead and clean the numerator up. Clean that up there. So we have x minus x minus, distributing that a negative across, delta x. So it looks to me like those x's cancel out, don't they? Over, then we have x plus our delta x. Okay, and of course this looks to me like we have x minus x, so we just have a negative x on top. If I didn't make any mistakes, we'll find out here shortly. Minus, because I'll catch it, over x, and then x plus delta x. I should have copied that delta at some point in time. Okay, so this right here now is what we're going to be writing. This is, what is that? Oh, forgot what the heck I was doing here for a second. So this is what goes in up here. Okay, That's what goes in up in the numerator. All right, so let's go ahead and we'll rewrite this part now. Actually, what are we doing here? We'll just rewrite the whole thing. Boom. Um, yep. Okay. So we're going to be rewriting all that right there. Okay. All right. Now what we'll want to do here is we're going to want to simplify this. Okay. So this can actually be rewritten. We're going to rewrite all this. Let's see here. We got to do something tricky. Rewrite all that. Okay.
1.
All right, let's rewrite this. And we'll just copy and paste like we normally been doing. Whoa, whoa, whoa. All right, copy, paste. Okay. All right, down here in the denominator, we're going to have this delta. We're going to be dropping this whole thing down into the denominator. All right. So we're going to end up with, I'll go ahead and write this part here, x times x plus, and then the delta x, and then I'm going to rewrite this delta x here, which is already in the bottom. I think what I'll do on this one is, if it'll let me, just copy and paste that. Yes, it did. So what's going to stay up in the numerator is this negative delta x. Okay. So we're going to have a negative delta x. How do you like that? All right. So what do we have here? Well, we have a delta x in the numerator, and we have a delta x down here in the denominator. You see this right here? Okay. So you can see that these delta x's are going to cancel out. They're going to cancel out, but we are still going to be left with, if you can imagine, this is really negative 1 times delta x up here. And so we're going to be left with a negative 1 in the numerator. All right, in the numerator. So let's just, let me just go ahead and copy paste all that. All right, so we're going to cancel this guy out and cancel that out. However, we'll be left with a negative 1 up here. Now what we can do now is go ahead and do the direct substitution. So we've got all that simplified down. All right, do the direct substitution, and we're going to end up with a negative 1 up here. And then in the bottom, we've got this x times x plus delta x, but you see delta x going to 0. So we're going to go ahead and do the direct substitution, plugging 0 directly in for delta x. And then we'll simplify this thing down. All right, we'll go ahead and write equal sign here. And so what do we have? Well, we end up with a -1 over, and x plus 0 is just x, and then x times x is x squared. X squared. See that? So we finally found the derivative. So it's -1 over x squared. However, we're going to write this as negative. We're going to take that negative and just bring it out front instead of leaving it up in the numerator. We'll bring it out front. Okay, -1 over x squared. So that was a little bit of work there. See, and it all boils down to what? A bunch of intermediate algebra steps. Just a bunch of intermediate algebra steps. And of course, this particular one here, simplifying this all down to that, was nothing more than, uh, you know, doing simplifying a fraction. Simplifying a fraction, right? Okay, so I said, try to find the pattern because there's some shortcut methods to all this. And see if you can do that. This one here is going to be a little bit more of a difficult pattern to try to find. But you've noticed that the power always is one larger. I don't know if you've noticed that or not. In the previous problems, we'd start with an x and or one a power one less than. In this particular case, we added 1 to the power, but because of that, it was down in the denominator. All right. Okay, so the next section, I said we do 5 problems in each section. This one was find the derivative by the limit process, so that should get you started there. Now what we're going to do is find the slope of the tangent line at a given point. So that means that to find that slope at the given point, we're going to need to find the derivative, okay? And then what we're going to do is we're going to plug in a number. All right, we're going to plug in a number. Let me quickly here just bring up this graph, okay? So this is the graph of the function x, right? So we just graph the function x, and we're going to be finding the derivative of this, which is what's the derivative of, if f of x is equal to x, what would its derivative be? All right, so that's what we're going to be doing. As you can see here, d over dx is equal to 1 no matter where you go no matter where you go. Okay. All right, so that's the story with that, and I guess we'll get started here in this new section coming up. Find the slope of the tangent line at a given point. Right. Oh, I noticed something. I guess we're still, I thought I'd shut this thing down. Alt-Shift-F. Yeah, something I forgot to do. Anyway, little thing popped up on the screen, said, hey, you're not recording that tab. Well, anyway, real quick here, back to this again. So this is the graph of f of x is equal to x, or y is equal to x. And you notice that everywhere we go, every point we go here, okay, on the graph, you see that d over dx? That's the slope of the tangent line at the point 2.1. See that x is 2.1, x is 2. Look straight down here, you got 2 here on the x-axis. But the derivative is 1 everywhere we go. So the slope of this line is 1, right? Okay. You're not catching what I'm talking about. We're going to talk about it more here in just a minute. All right. And once again, got to do that. I'm just learning this program here for screen recording and the Chrome web browser. It's not that great. Audio is kind of terrible, actually. And when I get some extra money, I'll buy something. It's a lot better. All right, so find the slope of the tangent line at the given point. That's what we want to do next. Okay, that ends this video.